Okay, 3 examples. We know how to integrate e to the power of x, but what do we do when there's a constant out the front? Well, think what you normally do when you're integrating or differentiating and you see a constant. Let's go back to something that you know well. If you're differentiating, say, 5x squared, you know what to do with x squared. You bring the 2 down the front and reduce the power by 1. What do you do with that 2 when it comes down the front? You multiply it by the 5. The 5 stays there and it's involved in the whole process. And if you differentiate this, you get 10x. The 5 is definitely involved. If you integrate 5x squared, then you know that you need to increase the value of the power of x, by 1 and divide by the new power. But that 5 just stays there, doesn't it? And when we differentiate this to check we get back to here, we actually do. So the 5 stays involved in both cases. So it makes sense that the 5 stays involved up here too. And if we know that e to the power of x integrates to become itself, then the 5 will come along for the ride as well. And we literally get that, and we just have to remember to add a constant. So that one's really straightforward. Okay, this one is not a perfect question. It would be a perfect question if we had the 3 out the front. So my first step is to change the question and write down the question I wish I'd been given. Now, why do I want the 3 out the front? Well, because 3 is the differentiation of everything that's up here in the power, the 3x minus 5. So if I have that there, I'm ready to go and I know what I'm going to get. Now, I've changed my question. I can't do that. If I'm going to multiply by 3 here, I need to multiply by a third as well to keep it the same as what I've been asked. Now I've made myself a question that's easier to do. How do I do it? Well, I know that integrating this part, I'm just going to get e to the power of 3x minus 5 plus c. But I've got to have my third there too. So 2 ways you can write it. You can write it like this. Or instead of having a third of this whole expression, you might prefer to just say I'm going to divide it by 3. Okay. Now, every time you integrate, you should differentiate just to double check you get back to where you started. So differentiating this, I would bring the 3 down the front, it would cancel with the other 3 and they would disappear. And then I would rewrite everything that I have and I'd just get this. Perfect. All right, this last one a little bit tricky. And the reason it's a bit trickier is we've got a different term out the front here. Now what we've got to check is, does it have the right power of x in it? Well, what happens when we differentiate this? Because if this is f of x, what would f dash x be? It would be 10x, wouldn't it? So this seems okay because we want 10x, but we've got 2x. So the powers of x are correct. We just need to adjust for the constant. So my first step again, write the question you wish you'd been given. If it helps, write the part with e in it first. And then think, if this is f of x up here, what's f dash x? F dash x is 10x. So this is the question I want, because this is the easy one to do. But I've changed my question. They gave me 2x and I wrote 10x. I can't do that. I've multiplied it by 5. Make up for it, I can divide by 5, like this. All right, now I can go ahead and say, I know how to integrate this part. I'm just going to get e to the power of 5x squared. But I've got my 5th here, which I can very quickly and easily account for like that. And then I need to always add a constant. Now let's double check that this is right by differentiating it and checking that we get back to this. To differentiate this function, I need to find f dash x, which would be 10x, bring it down the front. Now when 10x gets down the front, it's going to divide by 5 to make 2x. Perfect. And then after I've done that, I need to just rewrite the whole index expression. Perfect. So we're done. Here we've got a couple of questions to give us a bit more practice at integrating exponential functions. And each one of them has maybe a small trick that you could fall for. So this first one, we need to integrate one term at a time. Now all of these terms are really straightforward to integrate, but what we need to be careful with in a question like this is that we don't oversimplify it. Really common mistake is to look at something like the x and accidentally differentiate it and get 1, or minus 1 in this case, instead of x squared over 2. So remember, we're integrating. So for this first part here, when we integrate 1, we get x. When we integrate minus x, we get minus x squared over 2. And when we integrate the e to the power of x part, we get e to the power of x. And then, of course, the other thing we could forget is to add a constant to the end. This is an indefinite integral. There's no bounds on it, so we have to add a constant. Now, as always, when I've finished integrating, I differentiate each term to check that I get back to where I started. So if I differentiate x, sure enough, I'll get 1. Good. If I differentiate this, I'll bring the 2 down the front, change the 2 to a 1. The 2's will cancel, and I'll end up just with x. Perfect. And if I differentiate this, I get this. So I know I'm good. Okay, this second one has bounds, so it's a definite integral. So I'm going to start by drawing up my square brackets. I need to integrate one term at a time here. Now this constant 5 is going to stick around, but in a perfect world, I wish I was integrating 6e to the 6x. Now I can adjust for not having the 6 there by putting the 6 down below, and the 5 needs to stay. Now, as always, when I integrate something, I differentiate it to check I get back where I started. So if I differentiate this, the 6 comes down the front, cancels with the 6 down below, and they disappear. The 5 stays there, and I rewrite the exponential expression. So sure enough, I do get back to where I started. Integrating this part, people have different methods. Some people will say automatically, let's just raise the power by 1 and divide by the new power, and the 3 stays there. This is correct, and it's totally fine. If that's your method, that's cool. The 3's will then cancel though, and you'll just have x cubed. My method is to say, what power of x have I got? I've got x squared. So I start by writing my x's and saying I've got to raise that by 1 and make it x cubed. And then I think, what will happen if I differentiate that? The 3 will come down the front, and that'll change to a 2. I'll get 3x squared. Ah, perfect, I'm done. So I find that method just slightly quicker and easier, rather than having to cancel and have working that's a little bit messy and might take you an extra line. Now I put my bounds in like that. Now I need to sub in 2 where there's x, and then subtract, and then sub in 1. So subbing 2 in here, I've got 5e to the power of 12 over 6, plus 2 cubed, that's 8. Then I need to subtract, in brackets, 5e to the power of 6 over 6 plus 1. Now you'll put all of that in your calculator, which I've already done, and I got 135,299.8 to 1 decimal place. So I've rounded it off there. All right, the last question. The trick here is, instead of trying to reverse the quotient rule or something like that, which we don't know how to do, don't be worried about this fraction. Instead, change your question to one that looks easier. Now, I want to break this up into 2 separate fractions because then I can simplify them and integrate much more easily. So let's start. I'm going to do every line of working here, even though there's some parts of this I might do in my head. I'm not going to leave anything out. This is what I'm doing first. I've just broken up the fraction into 2 parts. Now I can simplify this. I've got the bases being the same, so I need to just subtract the indices. So this is actually e to the power of x. That's easy. And then this part, I can even write it like this, because that's going to make it much easier to integrate. All right, now I'm ready to actually integrate the thing. I haven't yet. All I've done is rewrite the question to make it look simpler. Now, integrating e to the x, I just get e to the x, so that part's nice and easy. This part's a little bit harder. I've got a number up there. So if I need to consider what happens when I differentiate this, which is that the negative would come down the front. Now I don't have a negative down the front. I can adjust for it though by dividing by it. Just like up here, we divided by the 6 that we didn't have. Now what happens if you divide by -1? Do I need to write it as a fraction and put it down below like I did with the 6? No, dividing by -1 is just going to change the sign. If you're not sure, write it down, have a look at it, and think about it for a sec. Does this differentiate back to this? Well, if I differentiate this, the -1 comes down the front, and negative will give me a positive there. And then I have to rewrite this. So I'll end up with plus all of the same stuff, and that's exactly what I started with. So yeah, I've got it right. Now I just need to add c, and I'm finished.